When you're solving inequalities, you solve them the same way you solve equations except for one small rule. That is, whenever you multiply or divide both sides of the inequality by a negative number, you have to change or reverse or flip the direction of the inequality sign. So if it was less than, it becomes greater than. That's when you multiply or divide both sides of the inequality by a negative number. If we have 2x plus 4 is less than 10, we're going to solve that for x, and we do that just like we would an equation. You want to get the x by itself, you need to move that 4 to the right side. So to move that 4 to the right side, subtract 4 from each side. We have 2x is less than 6. And then you need to move the 2 to the other side, divide each side by 2, x is less than 3. So if we were to graph that, it's saying that all x values are less than 3. It does not include 3, but anything less than 3. So since it does not include 3, to graph that, you put an open circle on 3, and then the arrow and the line goes to the left. That shows that x is anything less than 3. If you want to check that, just pick a number less than 3, substitute it back in, and it should make a true statement because this is the solution set. So anything inside here, when you substitute in for x, it should make a true statement. So you could put 0 in, could put negative 4 in, negative 10 in. Any of those should make a true statement. Let's say we go with negative 2. If we substitute negative 2 in for x into that original inequality, it's going to be negative 4 plus 4 is less than 10. Negative 4 plus 4, that is 0. 0 is less than 10. So that does make a true statement when you substitute negative 2 in for x. Now, if you wanted to get a false statement, you would go outside. So you would pick 5 or 8 or 10. If you substitute any of those in, it'll make a false statement, meaning those do not lie in the solution set to this inequality. If we have negative 7y is less than or equal to 63, you're going to solve that for y. Remember, when you multiply or divide both sides of the inequality by a negative number, you have to change, reverse, or flip the inequality sign. So to solve this, we would divide each side by negative 7. And now we change, reverse, or flip that inequality sign. So now y is greater than or equal to negative 9. To graph that, y does include negative 9, so we go with a closed circle on negative 9 this time. And the arrow goes to the right. Y is anything greater than negative 9, but it could also be negative 9. So closed circle on negative 9, arrow goes to the right. If you want to check that with numbers, pick any number in that set, such as negative 5 or 2 or 8. Put any of those in. It should make a true statement. So for this, let's go with 0. 0 is in that solution set. So if you substitute 0 in, it'd be negative 7 times 0. That is 0. 0 is, in fact, less than or equal to 63. It's not both. It's less than or equal to. So it is less than 63. That's a true statement. If you go outside that region, let's say negative 10 or negative 12 or negative 36, and you pick one of those numbers and substitute in, it should make a false statement. So let's say negative 10, just outside that. If we put negative 10 in for y, this should make a false statement. It shouldn't be true. It's going to be 70 is less than or equal to 63. 70 is not less than, nor is it equal to 63. So that is a false statement. So when you go outside that region, it's a false statement. Inside the region, in the solution set, it's a true statement. That's one way to check your solutions. We are going to solve this inequality. Negative 2 times the quantity n plus 2 plus 6 is less than or equal to 16. So to solve this for n, we want to isolate the n, get the n by itself, move everything else to the right side. There are a couple ways you can do this. Most people are going to jump to the distributed property here. They're going to, as soon as they see parentheses, they automatically think distributed property with the negative 2. But you could also move the 6 first, and then divide by negative 2, and then you would move that 2 once you're done with those. So there's a couple different ways you can do this. Since most people are going to use the distributed property, that's how I'll start this, is distributed property with the negative 2. Take negative 2 times n, that's negative 2n, and negative 2 times 2, watch your signs, that is negative 4. Go back through and combine the like terms. Negative 4 and 6, that is going to be 2. So negative 2n plus 2 is less than or equal to 16. Then subtract 2 from each side. You have negative 2n is less than or equal to 14. Watch your signs here. You're dividing by a negative 2. Whenever you multiply or divide both sides of an inequality by a negative number, you have to change or flip the inequality sign. So that's now going to be n is greater than or equal to negative 7. Now, if we think back to the beginning, I said there's a couple ways you could do this. We could have subtracted 6 and then divided by negative 2. So we would have n plus 2 is greater than or equal to negative 5. And then if you subtract that 2, it would be n is greater than or equal to negative 7. So same answer, two different ways to do it. To graph this, n is anything greater than negative 7, but it could also be negative 7. So put a closed circle on negative 7, and then the arrow goes to the right. That closed circle indicates that n includes negative 7, and the arrow to the right indicates n is anything also greater than negative 7. So n is greater than or equal to negative 7. Next, 2 times the quantity 7a plus 1 is greater than 2a minus 10. We have a's on each side of the inequality sign, so we want to get the a's to one side, everything else to the other side. Again, parentheses, you could divide each side by 2 here. Most people aren't going to do that, but you could divide each side by 2. This right side would be a minus 5. But most people see parentheses and they're thinking use a distributive property, so that's what we'll do here. Distributive property with the 2 makes that 14a plus 2. And the right stays the same. It's greater than 2a minus 10. Now to get the a's to one side, it's a good idea to keep your a or your variable positive when you're solving an equation or inequality. It just prevents you from making a mistake with a negative sign later on. So I'm going to subtract 2a and also subtract 2. Doesn't matter what order you do those in. You could do them in the same step if you wanted to. I'm going to subtract 2a and subtract 2. We end up with 12a is greater than negative 12. So we have 12a is greater than negative 12. Now be careful on your signs here. A lot of people think they need to flip the inequality sign here. You only change or flip the inequality sign when you are multiplying or dividing by a negative number. We are not dividing by a negative. Yes, there's a negative sign involved, but we're dividing by positive 12. So if you divide each side by positive 12, that's still a is greater than negative 1. The inequality sign does not change. We did not divide by a negative. We divided a negative by a positive, but the key there is you're dividing by a positive. So to graph that, a is greater than negative 1, you'd put an open circle on negative 1 because a does not include negative 1. And the arrow goes to the right. A is anything greater than negative 1. It does not include negative 1.